In this video, we'll look at some basic rules that help us find the probabilities of certain combinations of events. Think back to our last video, where we had a bunch of gumballs in a jar, and we calculated the probabilities of selecting a red, blue, or yellow gumball at random. We'll expand on this example in the next few videos. Two important properties to keep in mind that are worth reiterating here are that our probabilities are always between 0 for impossible events and 1 for absolutely certain events, and that the probabilities of all of our outcomes together always add up to 1. Here's a question to start us off. Suppose we reach into the jar and pull out a random gumball. What's the probability that it's red or blue? Well, 5 out of the 10 gumballs are red, and 3 out of the 10 gumballs are blue, so it seems logical to say that the probability of being red or blue should be 8 out of 10, or 8/10, 0.8, the sum of the two probabilities. An important thing to notice here is that being red and being blue are disjoint events, meaning they can't both be true at the same time. If we draw a gumball out, then it's either red or it's blue, but it can't be both. That's what makes these two things disjoint. What we've observed here works in general. Anytime you have two disjoint events A and B, the probability of A or B is just the probability of A plus the probability of B. We'll talk about what to do if the events aren't disjoint in just a bit, because this is actually a special case of a more general rule. Next, recall that the probability of drawing a yellow gumball is 2 out of 10, since 2 of the 10 gumballs are yellow. What if we turn that on its head and ask, what's the probability that the gumball we draw is not yellow? Well, since the only gumballs we have are red, blue, or yellow, if a given gumball isn't yellow, then it could be red or it could be blue. So what we need is the probability that a gumball is red or blue. We just got done calculating that. It's 0.8. But now notice something else. The probability that a gumball is yellow plus the probability that the gumball isn't yellow adds up to 1, or 100%. That's not a coincidence. These are two complementary events. And since any given event either happens or doesn't happen, their probabilities add up to 1. That gives us a quick way of calculating the probability of an event not happening. It's just 1 minus the probability that the event does happen. This is called the complement rule, and it's one of those probability rules that most people just kind of intuitively know. If the weather says that there's a 60% chance that it rains, that means there's a 40% chance that it doesn't rain. Nevertheless, the complement rule is one of the most useful things to know for probability, and you'll find yourself using it again and again. Now, let's add a little twist to our gumballs. See, what I didn't tell you is that, actually, 3 of the gumballs in this jar are spicy. That's going to make it interesting when you and your friends pick one out to try, since now there's a 3 out of 10 chance that you get a spicy gumball. Let's see what else we can figure out with this new information. We could ask, what's the probability that a randomly selected gumball is both red and spicy? Well, out of our 10 gumballs, exactly 2 of them are both red and spicy, so the probability is 2/10, or 0.2. Likewise, there's only 1 blue spicy gumball, so the probability that a random gumball is blue and spicy is 1 out of 10, or 0.1. What about yellow and spicy? Turns out there aren't any. It seems that being yellow and being spicy are disjoint events, since it's impossible, in this jar at least, to be both yellow and spicy. So the probability of a gumball being yellow and spicy is 0 out of 10. That's true for any two disjoint events. If A and B are disjoint events, then the probability of A and B is automatically 0, since they can't both happen at the same time. Okay, what if we want to know the probability that a gumball is red or spicy? At this point, I should probably make a quick note. Whenever we use the word or in probability, we usually interpret it as meaning one or the other or both. Anyway, take a moment and pause the video to see if you can figure this one out on your own. You should have counted a total of 6 gumballs that are red or spicy or both. So the probability is 6 out of 10 or 0.6. But let's take a moment and compare this to the or situation we saw earlier. If we add the probability of a red gumball, which is 0.5, and the probability of a spicy gumball, which is 0.3, we get 0.8, not 0.6. What gives? The issue is that if we add the red gumballs and the spicy gumballs, we actually overcount the gumballs that are both red and spicy. They get counted twice. But if we subtract it out once, then we make sure that we only count them once. And we do in fact get an answer of 0.6 for the probability of red or spicy. This is an example of another very important result called the addition rule. It tells us that if we have 2 events A and B, the probability of A or B can be found by adding probability of A plus probability of B, but then subtracting probability of A and B to deal with the overcounting. What if we did the same analysis with the probability that a gumball is yellow or spicy? Let's try out the addition rule. The probability of yellow is 0.2, and the probability of spicy is 0.3. What about the probability of yellow and spicy? Well, remember that being yellow and being spicy are disjoint in this jar. So the probability of being yellow and spicy is just 0. So in this case, we can just add the 2 probabilities. And that exactly matches what we said earlier about probability of A or B when A and B are disjoint. Our new addition rule works for our older situation, just by remembering what being disjoint means. So all in all, we've seen 2 basic rules. The complement rule, which lets us find the probability that something doesn't happen, and the addition rule, which lets us find the probability of A or B. And if A and B are disjoint events, then that gives us a little more information, telling us that the probability of A and B is 0.